In chemistry, we want to use numbers that are precise, but the precision of the answers we give when we're crunching problems is going to be limited by the measurements or numbers we start out with. We deal with this by paying attention to significant figures. When you work with data, there are two kinds of numbers you'll run across: exact numbers and measured numbers. Exact numbers are numbers we know by counting. The number is known exactly. For example, the number of seconds in a minute is 60. No more, no less, that's how it's defined. The number of eggs in a dozen is 12. There are 5 puppies in this litter. These are things we know by counting. Measured numbers are numbers you get by measuring. The exact value is not known. How accurate or precise the number is depends on what you use to measure it. In science, we only report the numbers we're sure about. We use significant figures to indicate the degree of certainty. Significant figures are used to indicate the precision of a measurement. Now, exact numbers are accurate to an infinite number of decimal places. The precision is infinity. There are infinite significant figures. For example, there are exactly 60 seconds in a minute. 2.54 centimeters is exactly 1 inch. 1 meter is exactly 1,000 millimeters. Notice that there are no decimals. There's no need for them because the numbers are exact. For measured numbers, the number of significant figures is the number of digits known with certainty plus one uncertain digit. For example, 2.2405 grams means that we're sure that the mass is 2.240 grams, but we're uncertain about the 10,000ths place. When we're given a measurement, there are rules for what does and what does not count as significant. Case number 1. We have a number, 3,090. Nobody told us this was an exact number, so we'll assume it's a measured number. There's also no decimal place. That's important here. Notice that we have 2 zeros here. The 0 in the 100ths place is called a captive zero. It's between 2 non-zero digits. The 0 at the end is called a trailing zero. Captive zeros are significant. They're known quantities. But trailing zeros are not significant if there is no decimal. Time for a quick quiz. How many significant figures in 12,009? If you said 5, you're correct. The 2 zeros are captive zeros. They count. How many significant figures in 99 million? The answer to this one is 2. The 6 trailing zeros don't count. They are not significant figures. And one more, 520 pencils. The answer here is infinite because this is an exact number. It was counted, not measured. So let's go to case 2, cases where there's a decimal. As in case 1, captive zeros are zeros that are between 2 non-zero numbers. They are always significant. Leading zeros are the ones that occur before the first non-zero digit. They are not significant. When you're dealing with decimals, your first significant digit is going to be the first non-zero number on the left. Even though trailing zeros were not significant in the numbers that didn't have decimals, they are significant if they happen after a decimal. One more time, captive zeros are the result of measurement. Leading zeros just tell us where the decimal place is. Trailing zeros are assumed to have resulted from measurement if they are after the decimal point. Quick quiz. How many significant figures in 55.0? The answer, 3. In this case, the trailing zero is significant because it comes after a decimal. Now, how many significant figures in 76.607? The answer is 5. The captive zero is significant. Now, how many significant figures in 0.00083224? The answer is 4. The leading zeros are not significant. They just tell us where the decimal place is. This works when you have units as well. In this example, there are only 2 significant figures. Although the zeros could be significant, maybe that's what the person got when they measured it, they could also be placeholders. We don't have enough information to say either way, so we can't count them as significant. Quick quiz. How many significant figures in 23.40000 grams? Answer: 7. There's a decimal point, so all of those trailing zeros are significant. So now you should know something about rounding and significant figures. Be sure to remember these when you're doing your chemistry problems.